Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2019. This is question number 11 from paper 1. This question is from the topic differential equation. In fact, applications of differential equation in which certain conditions are given for a curve and we have to find equation of that curve. Let us see what this question is. Let tau denote a curve y is equal to fx which is in the first quadrant and let the point 1, 0 lie on it. Let the tangent to tau at point P intersect the y-axis at yp. If P yp has length 1 for each point P on tau, then which of the following options are correct? In two options we are given differential equation and in two other options we are given their solution. So let us see how to solve this question. So if suppose we have a curve like this on which P point, say this is tangent, and P point is x comma y which meets y-axis at yp. So equation of tangent can be written as y minus small y is equal to dy upon dx into capital X minus small x. Here capital X, capital Y acts as variable for tangent. So to know the coordinate of yp, I will put x is equal to 0, which will give capital Y equal to small y minus x into dy upon dx. So these are the coordinates of point yp. So the distance between yp and p, which is p yp square, I am taking actually square of this distance. It would be x square plus x square into dy upon dx whole square. And that will be equal to 1. So after simplification, this gives dy upon dx whole square equal to 1 minus x square upon x square. Okay, now this equation tells us that my x should be less than 1. Already because curve lies in the first quadrant, x should be positive. So we can say that the domain should be from 0, 1. Closed bracket at 1, open bracket at 0. 1, 0 in fact is already given that it lies on this curve. Now corresponding to this equation number 1, I can have three possibilities for dy upon dx. One is that I take always positive sign, so it will be under root of 1 minus x square upon x, or I take always negative sign, so it will be minus of root over 1 minus x square upon x, or I take sometimes positive or sometimes negative. How it is possible? It can be possible if we till some interval in the domain take positive sign and then negative sign, or converse, or mixed of these things. But the problem here would be that let us say till q point we take positive sign and then we take negative sign. So that at q point on one side dy upon dx will be positive, on other side it would be negative. This expression can never be equal to 0. So there will be sudden change of value of dy upon dx at that point. So it will be like having a corner point that we have in a function like modulus at its vertex. So function will not have dy upon dx defined, but we are getting tangent at every point. So this is ruled out. Now let us see, we should take first one or we should take second one. This first one says dy upon dx will be always positive, so it says that function will be increasing. The second one says it will be decreasing. Now my curve was like this, that 1, 0 lies on it. So if we want curve to be in first quadrant, it should be like this only, which means the value of function should be higher before x equal to 1, which means function should be decreasing. If we take an increasing function, then definitely function should be coming from fourth quadrant. So this increasing value or dy upon dx positive value we should not accept, we should take only the negative value. So our differential equation for this would be y dash is equal to minus root over 1 minus x square upon x. So if I multiply by x, we get xy dash then plus root over 1 minus x square is equal to 0. So this is the differential equation. Let us see in which option it is given. So B is correct option for this one. C would have been correct for increasing, but it is not true for this question. Now, to solve this differential equation, which is dy upon dx equal to minus of root over 1 minus x square upon x, I think we just need to do the integration. To do the integration, we have multiple options. We can put x is equal to sine theta. We can put 1 minus x square is equal to t square, or maybe let me do one more way, minus of 1 minus x square upon x into root over 1 minus x square. So here you will have minus 1 upon x into root over 1 minus x square plus x upon root over 1 minus x square. Now this first one I can write like minus 1 upon x square whole divided by root over 1 upon x whole square minus 1. I have taken x square common from this under root plus x upon root over 1 minus x square. Now these integrals can be done by taking 1 upon x is equal to u and 1 minus x square is equal to v square. But it is not needed, we can do it directly also. It is just simple integration. So this will become, let me write it here, y equal to ln of mod of 1 upon x plus root over 1 upon x whole square minus 1, and here it will be minus of root over 1 minus x square plus c. Okay, now because 1 comma 0 lies on it, so we can put these values and we find c to be equal to 0. So the final answer here is y is equal to ln of 1 plus root over 1 minus x square upon x minus root over 1 minus x square. This mod can be removed also because x is positive. So this is the final answer. Let us see what answer they have given. Yeah, in D option you check y is equal to ln 1 plus under root of 1 minus x square upon x minus root over 1 minus x square. Exactly same that what we have got here. So D should be correct answer. And A option, if you see, it is exactly negative of this. It would have been possible with this C option. But A and C both are incorrect and B and D both are correct. You can check, this is the answer given. So this completes the solution of this question. I hope you liked this solution. Thank you so much. Stay tuned for more questions. Bye.